I spent the better part of last week just copying code snippets out of my IDE, pasting them into a chat window, waiting, and then carefully pasting the fix back in.
It's so tedious, right? And it's fundamentally slow.
Yeah.
That realization, that friction, is the critical shift. We're still treating these incredible models like, glorified chatbots.
When they could be working directly in the project, autonomously.
Exactly. We need to move beyond being the middleman.
So this deep dive is about taking these technical guides we have, these blueprints, and forging them into a real strategy. The goal is to build an autonomous, multi-agent AI coding team.
Our mission today for you is to extract the concrete tools, the specific GitHub workflows, and the crucial security measures you need to deploy a genuine 24/7 development team.
A team that lives inside your GitHub repository.
And fixes issues while you're sleeping.
Okay, let's unpack this core idea first.
Yeah.
Why bother with 3 different AI agents? Why not just use one, massive model and prompt it to do everything? Isn't that just adding complexity?
That's a great question, and it gets right to the heart of the architecture. The future here isn't one monolithic brain. It's a coordinated, specialized system. Think of it like a digital team. You want specific outputs for specific tasks, and different models give you different trade-offs. Speed, cost, and most importantly, control.
Control being the kicker.
Yes. Just like in a human team, you wouldn't hire your most creative architect to do a rigid, repetitive security audit, so we categorize them.
So tell us about the lineup. Who's on the team?
First up, we have the hybrid worker. We use Claude Code for this. This is your best reasoning engine. It's great for complex logic, but, and this is key, human approval is required before it merges anything.
So you're always in the loop. Safety first.
Yeah.
Got it.
Then you have the strict worker. For this, OpenAI Codex is ideal. This is where predictability is everything.
Boring, repeatable tasks.
Exactly. Writing unit tests, updating redomies, generating basic documentation. It has to follow a rigid, predictable process.
And finally, the one that sounds the most fun.
That's the fast worker. We use the cursor CLI for this. This is for complete autonomy. Full speed. It edits files, saves changes, and submits a pull request without you ever having to check in.
Pure velocity.
Pure velocity.
So how does organizing them into these specialized roles actually improve efficiency over just using a single powerful model?
Specialized roles give you precise control over the output. You can optimize for speed or rigidity as needed. Now, to make this system work, you need a foundation. If the agents are the workers, GitHub Actions is the robotic manager that tells them when to show up.
Let's define that jargon quickly. GitHub Actions are basically a robotic butler for your code.
Yeah, that's a great way to put it.
They just follow a recipe when a specific event happens, like someone posting a comment.
And that recipe needs 3 critical parts. First, the trigger. This is the magic word, maybe at Claude Fix or at Cursor Fix, that you type as a comment on a GitHub issue.
That wakes the bot up.
Wakes the right bot up. Second, and this is crucial for security, is the runner. You're not running this on your laptop. GitHub gives you a temporary computer, a virtual machine, that spins up securely, does the work, and then just deletes itself.
And the third part is the script itself, the workflow file.
The recipe. It's a YAML text file that details all the steps. Read the comment, check who the user is, wake up the AI, send the code, save the changes. It's the conductor. Beyond security, what's the practical advantage of using a temporary GitHub runner instead of running these tasks locally?
It prevents complex, resource-intensive operations from slowing down your own computer. Okay, let's dive into method 1, the safest approach, the hybrid model using Claude. The key here is that approval is always required.
The human stays firmly in the loop.
And that safety starts with permissions.
It's non-negotiable. The first line of defense in that workflow file is a guest list, a defined list of authorized GitHub usernames. If anyone else tries to trigger the bot, the action just fails.
Okay, so once you've secured who can use it, how do you instruct the bot without rewriting a huge prompt every single time?
You definitely don't want to do that. You save a standard set of instructions in an instructions.md file. This tells Claude its role, maybe expert senior software engineer, and sets expectations for its tone.
But just instructions for its personality isn't enough for code style, right?
No, because the AI is only as good as the context you give it. And the critical trick here, and this is a constant battle, I still wrestle with prompt drift myself, is using an agents.md file in the repository.
Tell me more about that specific file.
That file is your project style guide, but for machines, it details your coding rules. Always use TypeScript, indent with 2 spaces, All functions must be camel case.
And every bot reads this first.
Every single AI bot, no matter the model, is instructed to read that file first. This guarantees consistency. It stops the bots from contradicting each other's style.
So what's the outcome of this hybrid approach?
Claude reads the issue, reads the context, reads the style guide, creates a new Git branch with the fix, and then it comments back on the original issue with a clickable link to open the pull request for your final human review.
So if the AI is so smart, why is using agents.md so crucial instead of just telling it the style once in a prompt?
Contextual documentation ensures every bot consistently adheres to project standards. And that moves us to method 2, strict and deterministic using OpenAI Codex. Here, the focus shifts to total, uncompromising control. The AI only outputs text. The workflow controls everything else.
I want to pause on that word, deterministic. That means predictable. Can AI-generated code really be deterministic, or does that just mean the process around the code is rigid?
It's the latter. The process is absolutely rigid. The YAML file dictates everything. The branch name, the commit message where the file is saved, opening the PR. The AI's only job is to fill in the blanks with code.
So you're just focusing its execution?
Entirely. And the perfect use case for this is
Unit tests.
Unit tests. It's boring, necessary work. A human doesn't want to spend 2 hours writing jest tests for every edge case. You set the AI's role to QA engineer, specify the framework, and demand exhaustive coverage.
And what's the key to making sure the AI stays in that rigid lane?
The prompt has to be explicit. It must include output only the code. Do not talk to me. Do not explain anything, just the text.
And the workflow script just grabs that raw output.
Exactly. Captures that raw code and saves it directly into the right file, like my-function.test.js, before pushing it. No explanation needed, no conversation.
So does this deterministic setup fundamentally limit the AI's ability to reason? Or does it just focus its execution?
It focuses the execution, ensuring the output aligns perfectly with predictable file structures.
Okay, now for maximum speed, this is method 3, autonomous speed with the cursor CLI. This is where we run it in what's called headless mode.
Right, headless mode is just jargon for running a tool in the background without a user interface. It's perfect for an automated GitHub runner. We install the cursor CLI, and suddenly the AI has access to the command line.
And because it has terminal access, you can skip a lot of the complex YAML scripting we needed for Codex. You just give it the do-everything prompt.
Precisely. You're basically telling the AI to manage the whole Git process itself. The prompt literally says things like, create a new branch called feature 6, update the CSS file, verify the changes, commit them, and then use GAPR, create to open a pull request.
So that's the power analogy here. You type it cursor fix, close your laptop, go make a coffee.
And the PR is waiting for you when you get back. It's tireless, instantaneous development.
Whoa. Just imagine scaling this across an entire company to handle thousands of repo updates instantly after a big security vulnerability is found.
Humans can't match that speed. It's a different scale of maintenance. So since this is the fastest, most autonomous method, what practical steps should a manager take to audit its output effectively?
Auditing is managed by integrating immediate automated security checks before the PR is even created. Before we move on, let's take a quick break. Welcome back to Deep Dive. We've talked about speed and autonomy, but when you give a machine that much power, security has to be the very next thought.
Absolutely. If this AI team is working 24/7, we need a security guard watching over them.
And that guard is a tool like SonarQube.
Exactly. It acts like an advanced spell checker for your code, finding bugs and critical security risks like SQL injection vulnerabilities.
The key is integrating this scan before the code ever gets to a human reviewer. This is where the workflow gets really smart.
The process is simple. AI writes the code, SonarQube scans it, and if a security issue is found, SonarQube immediately tells the AI that wrote it to try again.
It creates a self-correction loop.
Right. The AI fixes the security issue on the spot using that feedback, and only then is the pull request created. This means the code reaching a human is already pre-vetted and cleaner. It cuts down on so much wasted time.
That dramatically improves the quality upstream. And my favorite concept from these guys has to be the triangle strategy.
Making the agents check each other's work?
It's AI peer review.
It's formalized AI peer review. So if Cursor writes the code, you immediately trigger Claude to review it, but with a different specialized prompt.
Yeah.
You tell Claude its role is a strict senior tech lead.
And the review prompt is the key here. You can't just say, look for errors.
No, you have to give it critical evaluation criteria. Tell it to look for performance bottlenecks, like nested loops inside other loops, or check for obscure violations of your naming conventions.
Right.
I saw a perfect example of this. An AI updated a config file correctly, but the reviewer, AI, the strict tech lead, commented that the main readme file hadn't been updated to reflect the change. It found a communication gap a human might have easily missed.
When you're using this triangle strategy, how do you stop the reviewer AI from just, agreeing with the first AI to save time?
The strict senior tech lead prompt enforces constructive but critical evaluation criteria, like performance metrics. It forces an adversarial role.
This whole setup can sound complex, but the sources really emphasize you don't need to deploy all 3 bots at once.
No, you start small. And we have a simple checklist for getting started.
Okay, what's first?
First, prepare your API keys. Claude, OpenAI, Cursor. A useful tip here is to use the Claude setup token command, which can tap into your monthly subscriptions and potentially save on costs.
Second, and this is an absolute necessity, add those keys as secrets in your GitHub repository settings. Never, ever paste your keys directly into code files.
Huge security failure waiting to happen.
Right. And third,
start with the safest method. Create one simple hybrid workflow with Claude. Get that YAML file running, requiring manual approval for everything until you've built up trust in the system.
Finally, let's talk about common pitfalls. I learned some of these the hard way. The first is the infinite loop.
Yes, a classic automation trap. You have to make sure the AI doesn't trigger itself.
How does that happen?
Well, if your workflow triggers on a new comment and the AI posts a comment like, I fixed it, that could trigger the workflow again.
So you have to filter that out.
Exactly. You check who the actor, the user of the comment is. If it's the bot, you break the loop.
The second mistake is ignoring context. If you don't spend time writing a solid agents.md file, the AI is just going to guess at your project's style. And it will probably guess wrong.
And finally, cost management. This is critical. Tokens are like water from a tap. Start with small, specific tasks like fix this one function in this one file.
Don't say, rewrite my entire app.
You will get a very large bill if you do that. Be surgical in your requests.
So what does this all mean for you, the listener? The core lesson here is this fundamental shift in your role. You go from user to manager.
You aren't replacing yourself. You're directing a team of fast, tireless workers who handle the typing, the coding, the testing, even the first round of security checks. You get to focus on architecture and strategy.
It really transforms the definition of a developer. Building this 2047 autonomous dev team feels like science fiction, but it's really just connecting existing tools through smart, repeatable workflows.
And it leaves you with a really interesting question to think about. If these autonomous AI systems, driven by strict templates and validators like SonarQube, increasingly write and review our code based on fixed rules, will this ultimate focus on efficiency lead to a global homogenization of programming style?
Will the unique creative quirks that human architects bring to software eventually fade away in favor of perfect, predictable, and maybe identical structure? Something to consider as you start building your own digital team.